Anyone? Hello. So I will take this class, right? Because Chiranjeevi sir is not available. So can you please tell me what has been covered so far? Hello.
Sir, chapter 8 completed.
Chapter 8 completed. Any doubt in chapter 8? Anything you want to understand once again in chapter 8?
So that last part,
What was the last part?
E distribution.
T distribution.
Yes, sir.
Okay. So T distribution is not actually the part of chapter 8, sampling distribution. T distribution is just a distribution, right? It is symmetric just like normal distribution. And when we use T statistics, right, or T distribution, when the variance is unknown. When variance is unknown, right, the sample mean x bar minus mu divided by sample variance, right? Sample standard deviation approximately follow T distribution. So उसको तो बस आपको याद करना है, उसमें कोई concept नहीं है. If you want to understand central limit theorem once again, all right, I can explain. Otherwise, I will start chapter 9. Right. Okay, so आप लोगों को पता है सेंट्रल लिमिट थ्योरम कैसे वर्क करता है? You know that if the अगर पेरेंट पॉपुलेशन कुछ भी हो तो उसका जो सैंपल मीन होता है, सॉरी, उसका पॉपुलेशन जो आप मीन ड्रॉ करते हो वो मीन नॉर्मल डिस्ट्रीब्यूशन फॉलो करता है अप्रोक्सीमेटली. ये चीज आप लोग समझ में आए अच्छे से? चलो कुछ दिखाते हैं आप लोगों को, ठीक है? फिर उसके बाद स्टार्ट करेंगे चैप्टर 9. So let me share the entire screen. Is it visible to everyone? Hello? Hello?
Yes, sir.
Okay. कि ये अच्छे समझ जाओगे तभी समझ में आएंगे, ठीक है? So basically देखो हम लोग क्या करने जा रहे हैं? We are going to draw a sample, right? Not one sample. In fact, we'll draw 10,000 sample, right? Each of size 1, and we'll take the average, and then we'll see what the probability distribution of the sample mean is, right? So probability histogram आप लोग पता है क्या होता है? So you see, this is the probability histogram, right, of from uniform distribution. देखो यहाँ पे जो original population है वो क्या है? यूनिफॉर्म है, ठीक है? So we are drawing a sample of size 10,000, right? Sorry, we are drawing a sample of size 1, right? And repeating this thing 10,000 times, है ना? इस चीज को हम लोग 10,000 times repeat कर रहे हैं. Let me share the entire screen. Okay. So what we are going to do is आप लोग काफी आगे हो तो डोंट वरी, राइट? संजीव सर आपको पढ़ाएंगे, कंप्लीट कर देंगे. So let me just suppose population, right? The observation in the population follows uniform distribution. Means the population is uniform 0, 1, right? So here हम लोग क्या कर रहे हैं? We are drawing a sample of size 1, right? So x1, x2 up to x 10,000, right? And now we are going to take the average of these observations, right? So first वाले का average लेंगे, so it will be x1. Second का average कितना होगा? x2. and इसका भी average कितना होगा? x 10,000, right? अब हमारे पास ये क्या हो गया? This is first of all, this is sample of size 1, sample of size 1, sample of size 1. And we are repeating this how many times? 10,000 times. Now we are going to plot histogram, right? So यहाँ पे देखो मैंने plot किया हुआ है. I have plotted here a histogram. Now you see almost all the observations, right, between 0 and 1 are equally likely to occur, है ना? देखो almost सभी का जो ये जो probability histogram है बिल्कुल flat है ना? Means all these observations between 0 and 1 are equally likely to occur. So यहाँ पे देखो क्या है? If I just draw a sample of size 1, right? A number between 0 and 1, right? A number between 0 and 1. So if I repeat this, I will get another number, a different number, 0.8185292. So this is the way to draw randomly observations from the uniform distribution. So here, when we take the average, right, these are the means, x1, x2, x 10,000, and this is the distribution of mean. Let us increase the size by 9, right? This time let us choose the size equal to 10, and then see what happens, right? So when we increase the size of the sample by 10, now you see the probability histogram is something like this. Just by increasing the sample size, you can see the shape of the distribution is very close to the shape of normal distribution, isn't it? Now the mean is same, right? Mean यहाँ पे देखो कितना है? 0.5, because when x follows uniform distribution, right? When x follows uniform distribution 0, 1, mean means expected value of the random variable is just b minus a, means 1 minus 0 divided by 1 plus 0 by 2, right? So 1 plus 0 by 2 is equal to 0.5. So देखो यहाँ पे mean कितना आ गया? 0.5, right? So in the second probability histogram also, the center of the distribution is again 0.5, right? Center doesn't change here, but the shape of the distribution is now different, right? We are having less variability in the observations. पहले वाले में देखो observations 0.0 से लेकर के 1.0 तक थे. 0 से 1 के बीच में जितने भी observations हैं, all these observations are equally likely to occur. But in the second case, you see observations have less variability, right? अब 0.2 से 0.8 के बीच में ही ज़्यादातर observations मिल रहे हैं. Why? Because we have increased the size of the sample, right? तो यहाँ पे देखो हम लोगों ने क्या किया है? सैंपल ड्रॉ किया कितने का? साइज 10 का, x11, x12 up to x1 10, then x21, x22, and then x2 10, right? And we are repeating this how many times? 10,000 times, right? X 10,000 to x 10,000 10. And then we are taking the average, right? So this one is x1 dot bar, x2 dot bar, and then x 10,000 dot bar. So now we have how many observations here? How many means? There are 10,000 means, right? This is just simulation. So to just understand the central limit theorem, right? Now you see, when we plot this, we have this probability histogram. The center of the distribution is the same, 0.5, right? Which is the center of the population, original population, but the shape is different. Now observations are having less variability, right? Observations are between 0.2 and 0.8, means the values which are less than 0.2 and the values which are more than 0.8 are almost impossible to occur, right? All the values are the values which are close to 0.5 are more likely to occur now. But beginning में क्या था, जब हमने sample का size 1 किया था, all the observations were equally likely to occur, right? तो when हम लोग जब एक sample draw करेंगे size 1 का, तो सारे observations between 0 and 1 are going to be equally likely. When we increase the size of the sample and take the mean, right? Repeat these 10,000 times and we plot the histogram, right, of the 10,000 means. This is the probability histogram, right? Now the values which are close to 0.5 are having more variability than those which are away from 0.5, right? जितना आप दूर जाओगे 0.5 से, you see the observations are going to be less likely to occur. मतलब ज्यादातर frequency कहाँ पे मिल रहा है, 0.5 के अराउंड मिल रहा है, right? So still the center is the same, right? X बार का जो center है वो अभी भी 0.5 है, but उसमें वेरिएबिलिटी अब कम हो गया है ना. Now let us increase the size by the factor 10. So let us choose the size 100, right? अब यहाँ पे देखो हम लोग क्या कर रहे हैं. Is it visual to everyone? Hello, am I audible? Hello.
Yes, sir. Yes, sir. You are audible.
Okay. So next time what we are doing is we are going to draw sample of size 100, right? X11, X12, X1, 100. Okay, X21, X22, X2, 100, right? And then X 10,000, 1, X 10,000, 2, X 10,000, 3. बस इसको समझना. Now we are going to take the average, right? Just to get the mean of the sample. This is, you can think of as the first sample, right? Sample 1. This one you can think of as a sample 2. So what we are doing is we are trying to get the idea about the sampling distribution of the mean, right? So when we draw the sample, we take the mean of the sample observations, right? This is what we are doing repeatedly. Sample number 10,000, right? So when we take the average, let us call this x1 dot bar, x2 dot bar, right? X 10,000 dot bar. So this is the x11 dot bar is the mean of the first sample. X2 dot bar is the mean of the second sample, right? So we are drawing a sample from the uniform distribution and we are taking the average, right? This way we are getting means of the sample, right? So देखो यहाँ पे जो mean है x bar, this is a statistic, right? This is a random. When we draw a sample of size of certain size, right? Let's say size n, and we put the observations, we put the values of x1, x2 into this function. It will give you the estimate, right? It will give you the value of the statistics, the realization. So these are, you can think of x1 dot bar, x2 dot bar are the realizations of the function x bar, capital X bar. So this is random. Each time when we draw a sample, you put the values x1, x2, xn into this function, you'll get realization of x bar, right? So these are the realizations. So when we have these realizations and we draw the probability histogram, we can get the idea about the distribution of sample mean, right? तो इसी चीज को हम लोग बोलते हैं sampling distribution of x bar. तो यहाँ पे देखो हमने sample draw किया 10,000 samples, यहाँ पे हमने sample draw किया 100 size का, right? और इसको repeat किया 10,000 times. So हमको कितने means मिले? 10,000 means मिले, ठीक है? अब इसका हम लोग probability histogram draw करेंगे तो पता चलेगा कि इसका sampling distribution क्या है. Now let us run this code and see what happens then. This time you see, is there any difference between the previous probability histogram and this probability histogram? Means size 10 और size 100 वाले में कोई difference आप लोगों को नजर आ रहा है? Is there any difference? Hello. Let me do the same thing for size 10,000 also. Then I will ask. Okay. Is there any difference between these four plots? Because some में एक चीज common है. What is that? The center is same. Hello, am I audible? Probability histogram इसको इसलिए बोलते हैं because the area, right? इन सारे rectangles का area add करोगे, you will get 1, right? So that's why and similar thing happens with the probability density function also. Area under the curve is equal to 1. That is why we call it probability histogram. है ना? So first of all, you see here all these distributions, right? This is sampling distribution of mean of size 1, right? Second graph is sampling distribution of mean when the size of the mean when the size of the sample is 10, right? And this is another sampling distribution of mean, right? But the size is 100, and this last one is also sampling distribution of mean, right? Sampling distribution of x bar, where x bar is summation xi divided by 10 divided by 1000, right? तो सब सैम्पलिंग डिस्ट्रीब्यूशन ही है मीन्स का. पहले वाले में मीन का जो साइज सैंपल का जो साइज है वो 1 था, सेकेंड वाले में 10, इन थर्ड द साइज ऑफ द सैंपल इज 100, एंड इन द फोर्थ द साइज ऑफ द सैंपल इज 1000. सो यू सी देखो यहाँ पे हो क्या रहा है. In each of these graphs, right, you can see clearly, in each of these four probability histogram, the center of the distribution is 0.5. सब में देखो सेंटर कहाँ पे 0.5, right? The only difference is that in the first one, the variance is large, right, in compared to the second one, right? And in the third one, the variance is even more smaller, right, than the variance in the second distribution. And in the fourth one, the variance is the smallest among all, है ना? देखो यहाँ पे सेकेंड फिगर में देखो 0.2 से 0.8 के बीच में ऑब्जर्वेशन है, बट फिर भी ये वैल्यूज पॉसिबल है. बट थर्ड फिगर में क्या है, द वैल्यूज आर नाउ बिटवीन 0.40 एंड 0.60, राइट? मींस ऑब्जर्वेशंस आर क्लस्टर्ड, राइट, अराउंड इट्स मीन 0.5, एंड द वेरिएबिलिटी इज स्मॉलर, है ना? अब वेरिएबिलिटी और भी डिक्रीज कर गया, क्योंकि पहले ऑब्जर्वेशंस स्टार्टिंग में 0 से 1 के बीच में ऑलमोस्ट ऑल द ऑब्जर्वेशंस थे, बट सेकेंड वाले में 0.2 टू 0.8 and third में 0.4 to 0.60. Now it is getting closer and closer to the true mean of the parameter, right? 0.5. और थर्ड वाले में देखो कितना है 0.46, which is very close to 0.5, and between 0.46 and 0.54. If all the observations are between 0. Almost 99%, right, or 99.99% observations are falling between 0.46 and 0.54. So you see, this distribution has also the same mean 0.5, but the variability is very very small because all the observations are between now 0.46 and 0.54. Both these numbers are very close to 0.50. So एक ही चीज इसमें हो रहा है, देखो जो वेरिएबिलिटी है, वेरिएंस है, वो डिक्रीज कर रहा है ना? पहले वाले में वेरिएंस सपोज वेरिएंस का फॉर्मूला यूनिफॉर्म डिस्ट्रीब्यूशन में क्या होता है, b माइनस ए होल स्क्वायर डिवाइड बाई 12, राइट? तो यहाँ पे 1/12 रहा होगा, सेकेंड वाले में 1/12 ऑल ओवर n मीन्स 10, तो और भी डिक्रीज कर गया, मीन्स 1/120. थर्ड वाले में कितना हो जाएगा, 1 और भी स्मॉल हो जाएगा, ठीक है, 1/1200, है ना? एंड फोर्थ वाले में 1/10,000. So variance डिक्रीज कर रहा है, ठीक है, बट मीन रिमेन्स द सेम. दिस इज व्हाट वी कॉल सेंट्रल लिमिट थ्योरम. तो सेंट्रल लिमिट थ्योरम क्या बताता है? सो पेरेंट पॉपुलेशन कुछ भी हो, so no matter which population you are drawing the sample from, right, the sample mean has approximately normal distribution. So suppose you have a population, right, we draw a sample, we draw many samples, right, from the population. Suppose the mean of the population is mu, and the variance is sigma square, right? I'm not saying that the population is normal. population could be uniform, it could be exponential, it could be gamma, Poisson, binomial, negative binomial, geometric, could be any population, right? Or the population which is unknown to us, right? So when we draw many samples from the population, we look at the sampling distribution, right? The sampling distribution is normal with the mean mu and variance sigma square divided by n. This is what we call central limit theorem. So X bar follows normal distribution approximately, right, with mean mu and variance sigma square by n. Or you can say Z equals X bar minus mu divided by sigma over root n. This is standard deviation. Will follow normal distribution with mean 1 and 0 and variance 1. This is what we call central limit theorem. The distribution of Z is normal with mean mu equals 0 and variance sigma square is equal to 1. Right? Hello? Am I audible? So let's start with the next chapter. I think you don't have any doubt in chapter 7. T distribution तो बस एक distribution उसको आप बाद में जब उसका use करोगे तो समझ जाओगे. So let me start chapter 9. So, 9th chapter is one sample estimation problem, right? So, first of all, chapter 9 and chapter 10 both comes in statistical inference. दोनों ही statistical inference के अंदर में study किया है, ठीक है? So first of all, let us try to understand what the statistical inference is. So, statistical inference you can think of as drawing conclusion about the population. Suppose you have a population and you want to infer something about the population, right? It is called statistical inference. So inferring something, drawing conclusion something about the population, right? It's called statistical inference. I'm just teaching, right? Formal note of Chiranjeevi sir से So because I don't have notes, I'm just directly teaching. So statistical inference you can think of as drawing conclusion, right? Or inferring something about the population by drawing a sample, right, from the population. So if you want to infer something, if you want to draw some conclusion about the population characteristics, such as population mean and population variance, right? These things are generally unknown to us. Means mean of the population, variance of the population, or any functions of mean and variance are generally unknown to us, and we want to conclude something or infer something about those unknown parameters, right? Because we are often interested in those parameters. So to infer something or draw any conclusion about the population parameters, what we do, we draw sample from the population. When we draw the sample from the population, sample helps us to infer about the population parameters. For example, suppose we have a population whose mean is mu, which is unknown to us, and variance is sigma square, which is also unknown to us. And I want to know about the mean, right? What the mean of the population is, or what the variance of the population is. So those things can be estimated or can be tested by drawing a random sample from the population. Once we draw the random sample, right, using statistical techniques, we can infer about the population mean. We can tell whether the population mean is this or that, or we can draw some conclusion about the population, right? So one of the main objectives of statistics is to draw inference about population from the analysis of sample drawn from that population, right? So there are two important problems in statistical inference. The first one is estimation, and the second one is testing of hypothesis. So today we are going to talk about estimation, right? And estimation, there are two types of estimation: point estimation and interval estimation. So इस लेक्चर में हम लोग सिर्फ पॉइंट एस्टिमेशन की बात करेंगे, ठीक है? Talking about the point estimation. So first of all, let us try to understand what the estimation is. So suppose we have a population, right? Its a size may be finite or infinite, and its a mean is, let's say, mu, and variance is equal to sigma square. So what is estimation? Estimation. Suppose I want to know, right, what is the exact value of mean, right, or what is the exact value of sigma square, or what is the interval in which I can be 90% or 95% sure that the mean of the population will fall into that interval, right? So this is what we call estimation, the technique by which we can guess, right, or you can say we can approximate, right, find the approximate value of the true value of the parameter is called estimation technique, right? Either the exact value or the interval which will contain mu or sigma square with certain confidence, right? So that's why there are two types of estimation: point estimator and point estimator and confidence interval estimator, right? दो टाइप के एस्टिमेटर होते हैं. फर्स्ट क्या होता है? We use the sample, so first of all, it is very hard to tell what exactly exact value of the mean mu and variance sigma square, right? But we can have some idea about these mean mu and variance sigma square by drawing sample from the population. So as you know, sample is a subset of the population, right? Population units. So population में units हैं, उनका हम अगर sample subset draw करते हैं, generally we use simple random sampling to draw the sample, right? Then using the sample, we can infer about the mean, variance, or anything else which we are interested in, any other characteristics. So mean and variance are the main characteristics of the population, है ना? And generally यही चीजें unknown होती हैं. मतलब population का mean क्या होगा, उसका variance क्या होगा, these things are generally unknown, right? And we want to infer about mean. We want to draw conclusion about mean. We want to draw conclusion about sigma square. We want to simply infer about mean and sigma square variance. So that is possible only when we draw a sample from the population, and using the sample observations we can have some idea about the mean and variance, right? And if we use the sample observations to find a single value which will approximate, which will estimate the mean, it is called point estimator. And when we use sample observations to find interval which will contain mu or variance of the population with certain confidence, right? Confidence we mean here with certain probability, right? 0.95 or 0.99 or 0.90, right? So this is called interval estimation, and the estimator we get is called interval estimate. Is this clear to everyone? हेलो, कुछ समझ पा रहे हो आप लोग? यहाँ पे देखो हम लोग एस्टिमेशन समझ में आना क्या होता है। एस्टिमेशन इज जस्ट जब भी आप देखो पॉपुलेशन कैरेक्टरिस्टिक को, ठीक है, आप एक तरह से roughly speaking, we can say roughly speaking, when you guess a population mean and population variance, right, just using the sample observations drawn from that population randomly, right, is called estimation, right. So estimation में दो टाइप्स के होते हैं, point estimation, point estimator, right, ये टेक्निक होता है estimation, and the statistics such as sample mean and sample variance which we use to estimate sample population mean, population variance are called estimator, right. और interval estimator क्या होता है? When we using the sample observation, when we construct an interval which will contain mean, population mean or population variance with certain confidence, right, with certain confidence, with certain surety, with certain probability, then the interval is called interval estimator, right. And for each sample we have a interval, we have different intervals. So suppose you draw a sample, we have then observations like 1.2, 1.3, and when you take the average, right, x bar, the x bar will now be the estimate. And when you construct an interval like 1.2 to 3.3, then that interval, right, is called estimate, interval estimate, right. So there are two types of estimates: point estimate and interval estimate. And the function, right, of the sample observations which we use to estimate mu and sigma square are called estimator. So let me give the definition of point estimator. So point estimate of some population parameter theta right. Suppose theta is a population parameter. Here theta could be mean mu, or it could be variance, or it could be population median, right, or it could be population mod, could be anything, right. To correct population parameter theta, so a point estimate, right, of a population parameter theta is a single numerical value, because we are talking about point estimator, right, is a single numerical value theta hat of a statistic script theta hat. So here this statistic script theta hat is called point estimator. तो देखो जनरली हम लोग किस चीज को एस्टिमेट करते हैं? वी ऑफन नीड टू एस्टिमेट द मीन ऑफ द पॉपुलेशन, राइट, और द वेरिएंस ऑफ द of a single population, or proportion P of items in a population that belongs to class of interest, or the difference in means of the two populations, right? So these are the things we generally try to estimate. Generally for population mean mu, right, the estimate is x bar, right, the sample mean, you can say. So here you see what is a theta? Theta is mean, right, population mean. And mu hat is equal to x bar. So you can say this is theta hat. So this is theta, right? This thing is theta, and the estimate of the theta is theta hat. So here the population characteristic is population mean mu, right? So you can think of this as a theta, right? And we want to estimate the population mean. So we use generally sample mean, right? Sample mean क्या होता है? When we draw the population, sorry, the sample from the population, a random sample, right? Take the average of that, we get the sample mean. So generally we use sample mean to estimate the population characteristics, population mean. So population mean is a population characteristic, and we want to estimate, we want to find the point estimator, right, of the population mean. So yeah, theta is the one of the characteristics of the population, and when we use x bar to estimate population mean, it is called point estimate. And here, what is the difference between estimator and estimate? Point estimator and point estimate. Let us try to understand. Suppose this is population, right? So we define a function x bar. Let us try to understand the difference. We define the function x bar, right, which is same as x1 plus x2 plus xn divided by n. So here you see this is a function of sample observations, right? Here x1 is the first observation, right? When you draw the sample, and x2 is the second observation. So these things x1, x2, xn are random, right? So when I draw the first sample, let's say sample 1, right? I can compute little x bar, which is going to be x1 plus x2 plus xn divided by n. So this x bar is the estimate because I draw the sample for the first time and I got these many observations. So here the value of capital X1 is little x1. This little x1 is the realization of the capital X1, because x bar here you can think of as capital script theta, right? Script theta, you can say. This one is estimated, and when we draw the sample, we get the realization of that, and this is now the estimate. This is now the theta hat. So this is the difference between estimator and estimate. This one script theta hat is estimator. Here when we use the sample mean to estimate the population mean, this capital X bar is the estimator, right? Point estimator of the population mean, and little x bar, the realization of x bar, capital X bar, is the estimate, right? Similarly, when we draw second sample, let's say sample 2, we get another mean this time, right? Let us call this x1 bar. So I will get x2 bar, right, which will also estimate the population mean. So it will be equal to x21 plus x22 plus x2n divided by n. So each time when we change the sample, we get different value of x bar, right? So the value of x bar is not fixed, right? The value of x bar, capital X bar, is not fixed. It changes, right? From sample to sample. It varies from sample to sample. When we draw another sample, it will have different mean. When I draw another sample, I will have different mean, right? So for the first sample, let's say I have mean x1 bar, right? I'm using the same function, capital X bar, which is defined as the sum of all the n individuals then by n. But when I draw a sample for the first time of size n, I may get the value x1 bar. When I draw the sample for the second time of the same size, I may get x2 bar, which is not going to be necessarily equal to x1 bar. So here x2 bar is another estimate of the point estimate of the population mean mu. So you see, these are the realizations: x1 bar, x2 bar, x3 bar, x4 bar, right? So there are infinitely many means you can get, right? So each time when you draw a sample, you will have a mean, right? So these means x1 bar, x2 bar are the realizations, and they are called point estimate, right? And the capital X bar is the estimator. So capital X bar is the estimator because this is the function of sample observations, right? So these things are random, and when we draw a sample, right, the value of x1 is now x11, x2, the value of x2 is x21, and value of xn is xn1. And when we take the average, we get the point estimate, right? So for the first sample, we have point estimate x1 bar. For the second sample, we have point estimate x2 bar, and so on and so forth. So this is the difference between estimator and estimate. Is this clear to everyone? हेलो, आप लोग पढ़ रहे हो या नहीं? नहीं तो फिर मैं कुछ और डिस्कस करते हैं. Okay. Similarly, we generally use a sample variance, right? Sorry, the estimate is for variance sigma square. The estimate is let's say sigma hat square s square, right? Which is 1 by n minus 1 summation xi minus 1 xi minus x bar whole square, right? So generally we use this sample variance to estimate population variance. So is this clear to everyone? So देखो यही population estimator होता है, ठीक है? So generally we use sample mean to estimate population mean, and we use sample variance, which is defined as 1 by n minus 1 summation xi minus x bar whole square to estimate population variance. So this time theta is this thing. This is the theta, right? Population characteristic, and this one you can think of as a theta hat. And now what is capital theta hat? Here this is the function, the random, this is statistics s square, which is 1 by n minus 1 summation xi minus x bar whole square. So this is random quantity, right? Random. Similarly, the capital x bar, which is 1 by n summation xi, right? I goes from 1 to n, is also random, right? And this one you can think of as a theta hat in the first case. Right? So let us discuss some general concept, right, of point estimation. So when we estimate the population characteristic, right? We draw the sample, and when we draw the sample, right, we compute sample statistics, the value of the sample statistics, such as the mean and variance, right? And they vary from sample to sample. Their values are different for different samples, right? So generally what we expect, the mean, right, the expected value of the statistics which we are using to estimate the population characteristics is same as the population characteristic which you want to estimate. For example, as you know that when x1, suppose the population is normal, with mean mu and variance, let's say sigma square, right, which is finite quantity. So here, suppose I want to estimate theta equals mu, right? Then, as we know, we use this x bar, which is defined as summation xi by n, right, to estimate this theta, right, the population mean. So generally, what we expect that the mean of this estimator, right, the mean of the estimator is equal to theta. This is the desirable thing. So an estimator having this property, right, is called unbiased estimator because x bar has its own sampling distribution, right, and it is called sampling distribution of sample mean. So because x bar is not a fixed quantity, it is a random quantity. Its a value differ, right, from sample to sample. So we can draw infinitely many samples, right, each of having the same size n. So we can get infinitely many values of x bar. So when we can get infinitely many values of x bar, we can plot the histogram, right? And when we plot the histogram, that is called the distribution of sampling distribution of x bar. And what we expect that the distribution of x bar must also have the same mean mu. If I want to estimate mu using x bar, so this is a desirable thing, right? This is what we desire to have desirable property for an estimator which we are using to estimate the population mean. So अगर हम लोग population mean को estimate करना चाहते हैं sample mean से, so this is the desirable property, right? This is what we expect from our estimator. So हम लोग चाहते हैं कि यहाँ पे जो estimator है उसका जो mean है, ठीक है, वो उस population characteristic के equal होना चाहिए. Means its expected value must be same as theta, right? And this thing happens here. You see, if x1, x2, xn is a random sample, right, from the normal distribution with mean mu and variance sigma square, and we use x bar to estimate mean mu, then expectation of x bar is equal to expectation of 1 by n summation xi, right, equals, since expectation is a linear operator, it is equal to expectation of summation xi, and since x1, x2, xn are IID, means identically, independently and identically distributed normal distribution with mean mu and variance sigma square, expectation of xi is equal to mu. So 1 by n summation for I from I equals 1 to n mu, and this is equal to 1 by n into n mu. So when we simplify this, it is equal to mu. So you can see x bar, expected value of x bar is equal to mu. Right. So if the original population is normal with mean mu and with mean mu and variance sigma square by n, right? Sigma square by sigma square, and then we draw sample, right? From the normal population, take the average, right? So I will get some quantity, and when we repeat this thing, I will get different, many values of x bar. So the sampling distribution of x bar is also normal with the same mean mu, but variance is sigma square by n. So you see the expected value of x bar is equal to mu. Variance is now decreasing by this factor. So the estimator x bar you can say is unbiased estimator, right? So the first concept we are going to discuss about is unbiased estimator. So an estimator, right, whose expected value is equal to the population characteristic theta, right, you want to estimate is called unbiased estimator. So I think it's already 10:59. So let us stop here, right? I have another class from 10 to 11. That's it for today. Thank you. Thank you all.
Good morning, all of you.
Good morning, ma'am.
How was your exam? Hello? How was your exam? Hello? Am I audible? Am I audible? Am I audible? Yes or no? Tell me. Hello?
Yes, ma'am, you are audible.
Okay. So why you are mute? Huh? Soumya? Soumya?
Yes, ma'am.
How was your exam? Hmm?
I'm average.
Average.
Yes, ma'am.
Okay. So all of you are acquainted and completed up to combinational and the class which we have started before your mid-sem, that was your sequential. So have you remembered anything about sequential or forgotten? Uras? अरे सचिन कहाँ गए? सचिन? सचिन? उरस? उरस? अर्नब दत्त?
यस मैम।
एग्जाम कैसा है?
अच्छा ही है मैम।
अभी भी तुम्हारा वहां पे नेटवर्क प्रॉब्लम हो रहा है ना? सही हुआ?
हल्का हल्का है मैम, इधर उतना नेटवर्क अच्छा रहता नहीं है।
और एग्जाम के टाइम पे कोई प्रॉब्लम नहीं हुआ?
नहीं मैम। मैम एक पेपर में एक दो जगह डाउट था, वो
अच्छा
एक के मैप का क्वेश्चन था, उसका सोल्यूशन ही उसमें ऑप्शंस में गलती दिया हुआ था।
अच्छा अच्छा।
चारों ऑप्शंस में से कोई सेटिस्फाई नहीं कर रहा था।
बाकी लोग का क्या डाउट वही है?
और मैम डीमल्टीप्लेक्सर तो हम लोग पढ़े ही नहीं थे, उससे भी क्वेश्चंस आ गया था।
जस्ट रिवर्स ऑफ मल्टीप्लेक्सर।
मतलब वही पढ़े नहीं थे हम।
डीमल्टीप्लेक्सर का कितना क्वेश्चन? वो तो कॉम्बिनेशनल पोर्शन में आता है ना। तो मल्टीप्लेक्सर पढ़े हो तो ईच एंड एवरी पोर्शन मल्टीप्लेक्सर जस्ट रिवर्स इज डीमल्टीप्लेक्सर। एक क्वेश्चन में ऑब्जेक्टिव का डाली थी डीमल्टीप्लेक्सर, तो उसमें मैं बताई थी। और आई हैव टोल्ड मेनी टाइम्स दैट अप टू कॉम्बिनेशनल सर्किट कंप्लीशन। तो तुमको पूछना चाहिए था कि मैडम ये पोर्शन मैं तो बोली कि सब कुछ आएगा, कॉम्बिनेशनल भी आएगा। सो कॉम्बिनेशनल डीकम में भी थोड़ा तो तुम भी अपना मतलब दिमाग लगाओगे ना। ठीक है, क्वेश्चन देखेंगे, कभी डिस्कस करेंगे। ओके, ठीक है। Okay, so today I will start the class. Okay, so have you remembered about this sequential circuit? Who can answer? First tell me whether you have remembered all this, then from that one I will start. So who can tell what is sequential circuit? Subham Patnaik.
Yes, ma'am. Ma'am, sequential circuit is a combination of both combinational and memory element.
Very good. Then what is flip-flop and what is latch?
That I don't remember.
Okay. Who can tell? Satyabata? What is the difference between latch and flip-flop? Satyavati, are you there? Okay, Arnav Datta.
Yes, ma'am.
Can you tell me what is the difference between flip-flop and latch?
I didn't understand the sequential circuit completely, so I don't.
Why?
The connection was weak, so the class was being disconnected every moment, so I can't hear it completely.
Okay, no problem. Once again, as again we will start, and this entire portion, the rest of the portion till the end same, that is based on the sequential circuit. So sequential circuit concept is very essential for you. Then for that, once again, I will just shortly, briefly telling that what is sequential circuit and what thing we are going to discuss. Okay. So this is visible to all of you, this screen.
Yes, ma'am.
Okay. So once again, I'm repeating just shortly that sequential circuit, so combinational circuit, all of you know that combinational circuit means whenever we are giving the input, the output or present output is depend upon present input, and the circuit is nothing but the combination of the input. So that's why combinational circuit. Okay. Then next one is the sequential circuit. Your entire circuit in the digital logic design subject, whatever the entire circuit, that will be divided into two types. One is combinational circuit, another is the sequential circuit. Combinational circuit means if the present output is depend upon present input, that type of all the circuit. So till now, whatever the circuit we have discussed, all are the examples of the combinational circuit. But if the present output is depend upon present input as well as past output, then that one is known as the sequential circuit. Because by using the sequential circuit, we are doing the operation by a particular sequence. Okay, so particular sequence may be suppose 0, 1, 2, 3, 4, 5, this like this. We are using a counter. So after 0, it should be count 1. So unless until it remembered the previous count was 0, so how it will be counting 1? Because my sequence is plus 1 to the previous one. So previous one is 0, then next one is 1. Then that one, it will be again keeping in mind, then 1 plus 1, next one is 2. Then that application, already I have discussed that one. Suppose for just like your car parking lot cases, what happens? Suppose first nothing is there, no gadi, no, that means no available. The vehicles are available. Then that counter value is 0. Then one vehicle will come. Then that will be just plus 1. It will be added, so that it counting to 1. Then that count is in its memory. So unless until the new vehicle come, it will be showing that only 1. When next vehicle come, then it will be just doing the next operation, that is plus 1, that is 2. So like this, it will be counting. So just addition of 1, that circuit is known as the combinational circuit. But remembering the previous one to which the addition operation is going on, that one is known as the memory concept. Okay, so this is the block diagram of the sequential circuit. So if we are giving the input, then we are getting the output. That output is stored in the memory element. मतलब suppose तुम्हारा पहला आउटपुट 0 आया, तो वही 0 आउटपुट तुम्हारा मेमोरी में स्टोर होके रहता है. फिर वही 0 आके यहाँ पे फिर कॉम्बिनेशनल सर्किट में इनपुट as a input, it will be fed. Then this input, this memory input and this current input, that will be passed to the combinational circuit, and that combinational circuit output is a new output. Now this output is now changes to 1. This output is kept in your memory element. Then this again, this one is fed to here. Then that will be changing my next output. So next output के लिए which inputs are responsible? For next output, which inputs are responsible? Hello? Hello? For next output, which inputs are responsible? Nobody? Arnav?
Memory element
Only memory element.
and the inputs which are given.
So most important क्या है? Next output के लिए important क्या है?
जो input आ रहा है.
हाँ, वो तो मेमोरी क्या कर रहा है एक्चुअली, जो इनपुट आ रहा है और ये इनपुट दोनों तुम्हारा जो कॉम्बिनेशनल सर्किट को इनपुट होगा. देन फाइनल जो आउटपुट आएगा दैट इज द नेक्स्ट आउटपुट. ओके, सपोज ये पहले इनपुट मेरा था 0 था, मेरा पहले आउटपुट मेरा 0 था, वही दैट इज द आउटपुट ऑफ दिस मेमोरी, दैट इज द इनपुट ऑफ दिस मेमोरी एलिमेंट, बिकॉज द मेमोरी एलिमेंट इज जस्ट स्टोरिंग द आउटपुट ऑफ द सिस्टम सर्किट. दिस 0 इज फिट टू द मेमोरी एलिमेंट, तो मेमोरी एलिमेंट का कंटेंट तुम्हारा 0 हो गया. That memory element content is now feed here. So again this one is 0. Okay, with this 0, whatever the external inputs will be applied with the combination of this and memory input, this combinational circuit works, and next output let it be. The next output is 1. Then this output is again storing the memory element. Okay, and again this 1 will be fed here. Then this output will again change to 2. Then this 2 is again stored in the memory element. So can you tell me that whatever the state of the memory element, that is the state of the output? Yes or no? Whatever the state of the memory element, that is the state of the output. State means content. Tell me. Whatever the content of the memory element, whether that is the content of the output, yes or no? Tell me.
Yes.
Okay. So the answer is correct. That is the yes. That means whatever the output you are getting, that output is stored in the memory element. Unless until the external input comes, this output will not be changed. Okay. So we can say that the content of the memory element is nothing but the output of the sequential circuit. All of you agree? The content of the memory element is nothing but the output of the sequential circuit. Okay. So now our emphasis in the sequential circuit is what is memory element, what type of memory element we are discussing. Okay. So depending upon the clock is applied to this memory element, there are two types of sequential circuit. One is asynchronous sequential circuit, another is synchronous sequential circuit. What is the difference between asynchronous and synchronous? If at a particular time, the entire memory element, this entire circuit will be working at a particular time and we will get the output at a particular time. So for that cases, all the component of the memory element should be synchronized so that we will get output. So, and that's why this is known as synchronous sequential circuit. That means all the component inside the memory elements are synchronized. Okay. And asynchronous sequential circuit means not at a particular time. That is maybe after some time. Suppose we are giving at one time and we are getting the output at a different time. So in that cases, we are telling that is the asynchronous sequential circuit. So उसी केस में सारे जो तुम्हारा एलिमेंट्स है मेमोरी के अंदर वो एक पर्टिकुलर टाइम में काम नहीं कर रहा है, उसमें एक काम कर रहा है एक टाइम पे, दूसरा काम कर रहा है दूसरा टाइम पे. इसीलिए उसी के जो भी तुम एक पर्टिकुलर टाइम पे इनपुट देते हो तो आफ्टर सर्टेन टाइम द आउटपुट विल कम. So that's why that type of circuit is behaving as a time delay devices. Okay. So have you understood this one once again? Arnab, समझ में आया? Or any doubt?
नहीं मैम आई है समझ में.
Okay. तो एसिंक्रोनस नॉर्मली क्या होता है कि वो उसमें जो मेमोरी एलिमेंट्स है वो एक टाइम पे सारा काम नहीं होता है. पहले एक टाइम पे ये काम होता है, उसके बाद वो काम होता है. तो इसीलिए हमारा जब सारा का काम हो जाएगा, सारे एलिमेंट का काम हो जाएगा, देन वी विल गेट द आउटपुट. सो input to output, that is some time delay. So for that reason, we are using that memory element, or that is that type of sequential circuit. But if in the sequential circuit, I want that at this moment, I want this output. So particular time, all the components should be worked together so that we will get the output. So that's why all the components should be synchronized. Okay, already I have given one example that suppose in the dance, in any dance performance, suppose 5 or 10 students are dancing. If all are not, dance coordination is not properly, then that at a particular time it will not be over. मतलब एक जो डांस जैसा करता है वैसे अगर सब प्रॉपर्ली नहीं करेंगे तो उसी टाइम पे कंप्लीट नहीं होगा. लेकिन एसिंक्रोनस पे क्या होगा, पहला पर्सन का डांस के बाद सेकंड पर्सन डांस के बाद थर्ड पर्सन अगर वो होगा तो दैट इज जस्ट लाइक योर एसिंक्रोनस सीक्वेंशियल सर्किट. ओके, जस्ट लाइक. So this is both the difference are there, and basically the difference is based on the clock signal. So what is clock signal? That this is the clock pulse. So when the clock pulse is applied to the memory element, that one is known as the sequential, and the example is flip-flop. And when the clock pulse is not applied, or if only the label triggered clock pulse is applied, then that type of memory element we are telling as latches. Okay. And last class we have just discussed about the latches. So storage element. So basically in the sequential circuit, our emphasis on the storage element, because the storage element content is nothing but the content of the output of the sequential circuit. So अगर हमको जो हमारा कंटेंट चाहिए, मेमोरी का कंटेंट चाहिए, that means वो हमारा आउटपुट चाहिए. तो तो वो आउटपुट के लिए हम मेमोरी का जो एलिमेंट है वो कैसे डिजाइन करेंगे, दैट इज आवर चैलेंज. So in sequential circuit, we have to design the memory element part so that our output should be like this. Output should be means the memory content should be like this. Okay. So there are the different memory elements. One is latch and another is the flip-flop. And the basic difference is based on the clock pulse. The clock pulse is nothing but continuous pulses. Okay. And continuous pulses means it is nothing but combination of 0, 1, 0, 1. So there are two types of response. What do you mean by response? So when you apply the clock pulse, then your memory element will be working. So that will be known as the response to the clock signal. So how it will be respond? So either it will be label triggering or it should be AS triggering. So triggering means जब apply होगा तब वो काम करेगा, वो trigger करेगा circuit को. So label triggering मतलब there are positive labels. So clock pulse का जब positive label में वो रहेगा, when the clock pulse, it will be continuously changing positive, negative, like this. So when it will be in the positive label, then the circuit will be working. And during the negative label, it will not be working. Like this, ACE triggering positive base and negative base. So during this positive base means when the clock signal is changing from 0 to 1, the circuit will be activating. And when it will be from 1 to 0, it will not be activating. So like this in the negative base, from 1 to 0, it will be activating, and other cases it will be not activating. Okay. And this is SR latch with NOR gates. So this first one is latch. So latch is nothing but memory element. And the memory element means it is used to store a single bit element because we are using for binary system. And binary generally we are using either 0 or 1. So either we are storing in the memory element 0 or at one time. So for that cases, we have to design the circuit. And this is the basic circuit diagram of latch, or we can say that memory element. Have you understood? Already I have discussed these things. Only I am just taking the revision of these previous classes. Up to this, all of you clear? Or any doubt? Hello?
No, ma'am, no doubt.
Okay. So this latch, have you understood? Latch operation?
Yes, ma'am.
Okay. So latch operation, what is the meaning of this latch? So this latch means only two inputs are there. One is S, another is R. S means set and R means reset. S set means I want that the memory element content should be set. Okay. So for that cases, I have to give the input to the S as 1. So output will be changes to 1. And reset. So when I will give the input as R is equal to 1, the output will be 0. So from this diagram, we can see that, and here what happened, two inputs are there, S and R, and two output. One is Q, another is the Q dash. So here two output, actually in the circuit, only one output, because we are telling that this is a 1 bit storage element, only one. So only one मतलब either वो 0 रखेगा स्टोर करके, नहीं तो 1 रखेगा. तो यहाँ पे दो आउटपुट नहीं, actually this is only one output, and this output is just complement of this one. Okay. So अगर हम बोलते हैं कि अगर स्टेट हमारा 0 है मतलब Q तुम्हारा 0 है, अगर तुम्हारा स्टेट 1 है मतलब Q तुम्हारा 1 है. So here once again I am repeating, I have explained this one. So if S is equal to 1, you can check that when S is equal to 1, your Q should be 1. Okay. And if Q1, so Q dash is 0. And with this condition, when we applied 0, 0, मतलब वही 1, 0 था और Q dash 1, 0 था, उसी condition में जब हमने एस आर वैल्यू को चेंज कर लिया, 0 कर लिया, तब हम लोग क्या देखे कि अगर प्रीवियसली मेरा 10 था, अभी भी मेरा 10 रह रहा है. तो दैट मीन्स we can conclude that when both the inputs are 0, there will be no change. Whatever the content in the memory, that will be remain as it is. Okay. Next, what happened with this one? Again, we have changed the input condition as S को 0 कर दिया, R को 1 कर दिया. मतलब अगर reset input को मैंने activate किया है, 1 किया है, तो आउटपुट क्या होना चाहिए? रीसेट होना चाहिए. रीसेट मतलब 0 होना चाहिए. So you can check here that output is Q is 0 and Q is 0 means Q dash is 1. Okay. With this condition, suppose I changes to 0. So what happened? If I am changing to 0, again I am checking that whatever the previous content of the Q and Q dash, that was 0, 1, and now it is again Q dash is 0, 1. Means any condition, whatever may be the previous condition, अगर मेरा present condition 0 होता है, तो वो जो पहला उसका आउटपुट रहा होगा, वो उसको मेमोरी के नाम पे रखेगा, उसका चेंजेस नहीं होगा. Okay, but when both the inputs are changes to 1 and 1, this condition is not satisfying, because we should know that we require that Q and Q dash should be complementing each other. But when both the inputs are 1, 1, these outputs are coming 0, which is forbidden state or invalid state. Okay, so this one is known as SR latch with NOR gates. So इसका जो physical significance क्या है? Why it is known as latch? Just like your door latch, we are using this latch. That means once the door is closed, then whatever the content inside, that cannot be go outside, or whatever the content outside, that cannot be come to inside. But the little bit different in case of your circuit cases, here also same thing. Once you are setting that this condition, the output cannot be changes unless until the input will be आउटपुट और मेमोरी क्या होना चाहिए? सेट होना चाहिए. सेट होना चाहिए मतलब क्या होना चाहिए? 1 होना चाहिए. देखो इसमें देखो, जब एस वैल्यू तुमने 1 डाला, यहाँ पे तुम्हारा 1 ही आया, और वही हमारा लॉजिक है कि जब हम एस को 1 देंगे तब तुम्हारा क्यू वैल्यू 1 होना चाहिए. ओके, और जब आर को 1 देंगे तब उसका रिसेट होना चाहिए. तो एक्चुअली इनपुट हम क्यों दे रहे हैं? Why? Because if we are not giving the input, then we cannot control that logic सॉरी वी कैन नॉट कंट्रोल दैट मेमोरी एलिमेंट, ये हम अपने तरफ से कंट्रोल करेंगे, इसीलिए हम उसको इनपुट दे रहे हैं। मतलब अगर मुझे चाहिए 1 चाहिए तो मैं एस इनपुट को अगर 1 दे दूंगी तो वो 1 होके रहेगा। And unless until if I will change that input condition of S1 to 0 or anything else, it will not be changing. Okay, तो इसीलिए we have given the two inputs. So यहाँ पे देखो, यहाँ पे जब तुम 1 देते हो वो Q 0 कर लेता है, फिर यहाँ पे जब भी तुम ये फिर और हमारा जो 0-0 में क्या होता, मेमोरी कंडीशन था, लेकिन यह भी देखो 1-1 कंडीशन में देखो पहले हम क्या लिए थे, 1-0 लिए थे, तो आउटपुट क्या आया था, 1-0 आया था। जब 1-0 कंडीशन के बाद 0-0 लिए थे, फिर वही 1-0 आया। मतलब यहाँ पे 0-0 में मेमोरी कंडीशन होता है, बट यहाँ पे जब उसने 1-0 लिया था तो आंसर तुम्हारा 0-1 आया, एंड जब 1-1 लिए तो वही 0-1, दैट मीन्स 1-1 कंडीशन में मेमोरी कंडीशन अराइज होता है। तो जस्ट इन्वर्टिंग कंसेप्ट, ओके, बट सेम थिंग बट इन्वर्टिंग कंसेप्ट। सो इन्वर्टिंग के लिए तुम इसको ऐसा लेके ये नेगेटिव लॉजिक अप्लाई कर सकते हो, नहीं तो अगर तुम डायरेक्टली इसको एस डैश ले सकते हो, इसको आर डैश करोगे और नैंड गेट यूज करोगे, देन ऑल्सो वी आर गेटिंग वट एवर आवर लॉजिक। मतलब जब 0-0 दोगे तब 1-1 आएगा। ओके, सो इसको डायरेक्टली भी तुम एस डैश आर डैश लेके भी कर सकते हो, क्योंकि जस्ट देखो वहां पे मेरा 1-1 लास्ट कंडीशन जो 1-1 कंडीशन में मेरा फॉरबिडन और इनवैलिड कंडीशन आया, बट यहाँ पे देखो वही चीज 0-0 कंडीशन में मेरा 1-1 आता है, वो मेरा फॉरबिडन और इनवैलिड कंडीशन आता है। मतलब अगर नैंड एंड लॉर्ड को लेके तुम जो लैच बनाओगे तो ये जस्ट तुम्हारा लिटिल बिट नेगेटिव कॉन्सेप्ट आएगा। ओके, इसीलिए तुम इसको अगर इनिशियली तुम एस डैश से आर डैश ले जाओगे तो ये तुम्हारा सही आ जाएगा। ओके, तो इसीलिए हम जनरली नॉर भी यूज करते हैं, नैंड भी यूज करते हैं। ओके, तो दैट इज द नथिंग बट द योर लैच। बट what is the problem in the latch? Due to some problem in the latch, we will use the your clock signal. Okay, so what is the problem in the latch? In the latch, when we are giving the input is changing, the output is changing. Okay, but suppose for a particular time I want that s is equal to 1, so it is okay. s को मैंने 1 दे दिया तो वो 1 रखा, लेकिन मुझे चाहिए कि जो 1 है वो माने 20 मिनट्स तक 1 होके रहेगा। लेकिन अगर वो सिस्टम टोटल सर्किट 5 मिनट के बाद वो ऑटोमेटिकली इनपुट चेंजेस हो रहा है, तो मेरा क्या होगा, अगर मुझे चाहिए 20 मिनट्स के लिए 1 रहेगा तो उसके बीच वो 5 मिनट के बाद फिर से चेंज हो जाएगा, अगेन 5 मिनट्स के बाद वो फिर से चेंज हो जाएगा। तो मेरा 20 मिनट के बाद वो 1 रहेगा या 0 रहेगा, कैन आई टेल श्योरली? आर यू गेटिंग माई पॉइंट और नॉट? हेलो हेलो, तो जैसे मैं एक एग्जांपल दी थी, जैसे कि होटल में अगर तुम चाहते हो कि तुम एक बजर ऑन की हो कि तुम्हारा जो प्रॉब्लम है कि तुम्हारा कुछ अंदर में लॉक काम नहीं कर रहा है, तो तुम इन्फॉर्म करना चाहते हो कि होटल के जो हाउसकीपर है किसको इन्फॉर्म करना चाहते हो कि वो तुमको रिस्पॉन्ड करे, तो इसीलिए तुमने वो जो बजर है तो उसे ऑन कर दिया, मतलब सेट कंडीशन में डाल दिया, तो that will be just blinking or that will be just the light will be glow unless until that will be responded. Okay, लेकिन अगर तुम उसमें सपोज ऐसे करेंगे, लैच हम यूज करेंगे तो लैच वो 5 मिनट्स के लिए काम करता है, तो अगर तुम उसको ऑन करोगे तो वो 5 मिनट्स के बाद ऑफ भी हो सकता है कि नहीं? हेलो,
Yes, ma'am.
जब 5 मिनट के बाद ऑफ होगा तब वो जो उसको कैसे पता चलेगा कि तुम्हारा मतलब प्रॉब्लम हुआ है कि नहीं, क्योंकि तुम चाहते हो कि तुम्हारा जो प्रॉब्लम है जब तक वो सॉल्व नहीं होता, मतलब रिस्पॉन्स नहीं हो जाता है, तब तक उसको 0 नहीं होगा। तो वो जब तुम्हारा रिस्पॉन्ड करता है वो देखता है कि देयर इज ए 1, so that the buzzer is high, that means there is a problem in that room, so वो जब फिर वो 0 करेगा till any problem is not arising. So that will be totally controlled by you. But if we are putting the memory just as a latch, then it will be automatically changing. मतलब वो 0 1 0 1 होता जाएगा, but that cannot be controlled by you. So whenever only the thing is that only the time delay is requiring. That means मुझे इतना टाइम पे मैंने 0 दिया है, इतना टाइम पे मुझे 1 देना आना है. तो उसी केस में हम लोग एसिंक्रोनस सर्किट या फिर लैच को यूज कर सकते हैं. बट जहां पे मेरा कंट्रोलिंग की जरूरत होता है वहां पे हम लोग फ्लिप फ्लॉप यूज करेंगे. Okay, and how that latch is converted to flip flop? If I am adding the extra input, that is the clock signal or the enable input to the circuit or to the latch, then that latch becomes flip flop. Okay, तो वो जो हमारा जो सर्किट था, प्रीवियसली जो सर्किट था, that was like this one. This portion is nothing but latch. LATCH. यहाँ पे हम बोल सकते हैं कि ये मेरा S डैश ले रही थी, यहाँ पे S डैश, यहाँ पे R डैश, जो हमने वहां पे देखे प्रीवियसली S डैश R डैश लेके ये जो सर्किट है वो सर्किट मेरा लैच है. उसी सर्किट के साथ अगर मैं एक्स्ट्रा एनेबल इनपुट या फिर एक क्लॉक सिग्नल अप्लाई करूंगी तो हाउ आई विल गिव दैट वन. उसके साथ थ्रू ए नैंड गेट, ये नैंड गेट सर्किट के साथ हम लोग एनेबल लाइन यूज किए हैं. विद द नॉर गेट वी कैन ऑल्सो ऐड ए क्लॉक सिग्नल. ओके, बट उसी नॉर गेट के साथ अगर हम एक डायग्राम अगर ये गेट लगाएंगे तो वो एंड गेट लगाएंगे. लेकिन अगर नैंड लैच के साथ अगर लगाते हैं तो उसमें नैंड गेट यूज करना पड़ेगा. सो दैट इज जस्ट difference between the NOR circuit and the NAND circuit. Okay, so you can check here that in this latch, the extra or another input is connected to this latch through like this. So this is my final input. This is S through a NAND gate. This one is coming, that is the S dash, and this enable one is also connected to this one. And this is another NAND gate, this is the R. And now this entire one I can tell up to this is known as, entire one is known as, क्या बोल सकती हूँ, बोलो, हेलो हेलो, हेलो, रिस्पॉन्ड मी.
Yes, ma'am.
तो क्या होगा? So this part is known as latch. Okay, and with the input change, जब तुम्हारा input change होगा, so output is automatically changing. But if I want the control over the latch, then we have to add the clock signal or enable signal to the latch. So how we are adding? By putting extra NAND circuit or NAND gate to the NAND latch and AND gates to the NOR latch. अगर हम NOR latch यूज करेंगे तो ये वाला सर्किट मेरा AND गेट होगा. अगर मैं NAND वाला latch यूज करती हूँ तो ये वाला सर्किट मेरा NAND गेट होगा. तो इसमें क्या करूंगी, NAND गेट, एंड दिस इज माय फाइनल इनपुट. तो दिस एंटायर सर्किट का फाइनल इनपुट क्या है? एस आर विथ ए enable signal. And final output क्या है? फाइनल आउटपुट क्या है? आउटपुट क्या है बोलो? अरे आउटपुट क्या है? What it is seeing from the diagram? हेलो,
You.
हाँ, वही जो आउटपुट था तुम्हारा, नैंड का आउटपुट था, वही तुम्हारा अभी भी आउटपुट है. ओके, सो Okay, so this one now this diagram. Can you tell me this diagram? Now this diagram having how many input? S, R and enable line, and how many output? Q and Q dash. Q dash is nothing but only one input, but we are representing as Q dash. So now this block diagram is known as what? I have written here also.
Flip-flop.
Okay, so this one is known as flip-flop, but only this part is known as latch. So with the latch, if we are adding an extra controlled input, then that latch is converted to flip-flop. Okay, and now we are discussing so many types of flip-flop. अभी हम लोग क्या कर रहे थे कि SR लैच पढ़ रहे थे. अभी वही जो लैच है हम पढ़ेंगे SR flip flop. Okay, that means now the input is here S and R. वो ऑटोमेटिकली यहाँ इस एंटर को मतलब काम करेगा, बट हम लोग जो इनपुट देंगे कहाँ पे देंगे? S and R को देंगे. प्रीवियसली हम कहाँ पे दे रहे थे? यहाँ पे दे रहे थे. ये जो S डैश R डैश था वहां पे दे रहे थे, तो वो एक लैच के जैसे काम कर रहा था. अभी हम कहाँ पे इनपुट देंगे? फाइनली एस और आर को देंगे विथ enable signal. So when we are giving the input S and R with the enable signal, so whatever the condition is arising, that one is known as SR flip-flop. Okay. So now we are just discussing the truth table of this SR flip-flop. Okay. So in this case, the first condition is that when the enable is 0 and S is the next state of Q. So what अरे व्हाट यू जस्ट अज्यूम, टेल मी, क्या मतलब समझ रहे हो? बोलो. नेक्स्ट स्टेट ऑफ क्यू. प्रेजेंट स्टेट, नेक्स्ट स्टेट, आई हैव एक्सप्लेन. Can you tell yes or no? Otherwise, I will proceed. कोई बता सकता है? Okay, so present state and next state means suppose Q value अभी तुम्हारा Q है तुम्हारा 0. So that is the present state is 0. Then that Q or 0 value is again fed to the combinational circuit and next output is coming as 1. So that output is now the output of the memory element. जो यहाँ पे हमने डिस्कस किए थे कि यहाँ पे अगर मेरा 0 रहता है, देखो यहाँ पे अगर मेरे पहले अगर 0 रहा है तो इसका प्रेजेंट स्टेट है 0. देन अगर चेंज होके तुम्हारा आउटपुट 1 आता है तो नेक्स्ट मेमोरी एलिमेंट कंटेन इज 1. सो द नेक्स्ट स्टेट इज व्हाट? अरे नेक्स्ट स्टेट इज व्हाट? टेल मी. 1. ओके. सो प्रेजेंट स्टेट, नेक्स्ट स्टेट मतलब क्या है? जो करेंट इनपुट है, जो करेंट आउटपुट है, दैट वन इज नोन एज द करेंट स्टेट. वाई स्टेट? मतलब बिकॉज इट इज टेलिंग दैट द मेमोरी कंटेंट को वो स्टेट बोला जा रहा है, और अभी जो उसका आउटपुट है दैट इज द प्रेजेंट स्टेट, एंड वो जो नेक्स्ट आउटपुट आएगा दैट विल बी नोन एज द नेक्स्ट स्टेट. अगर मैं अभी अज्यूम की हूँ 0 0, अगर नेक्स्ट मेरा 0 1 आता है तो नेक्स्ट स्टेट इज 0 1, वेयर एज प्रेजेंट स्टेट इज 0 0. ओके. सो दैट इज द स्टेट ऑफ द आउटपुट. Okay, so what is written here? So when the enable is 0 and S is don't care, R is don't care, the next state of Q is no change. Okay. तो हम लोग क्या जानते हैं, देखो SR कंडीशन जो हमारा लैच में था, तब देखो कौन से कंडीशन में मेरा जो मेमोरी और नो चेंज रहा, कौन से कंडीशन में, जब 1-1 रहता है, देखो जब 1-1 रहता है, so whatever my present state, that is my next state. Yes or no? Have you understood this one? देखो अगर मेरा प्रेजेंट स्टेट 0 है, देखो 0-1 मतलब स्टेट क्या है, 0-1 मतलब स्टेट क्या है, 0 है, क्योंकि हम लोग स्टेट किसको लेते हैं, किसका लेते हैं, 0 माने क्यू का लेते हैं, क्यू डैश इज ऑटोमेटिकली द कंप्लीमेंट ऑफ क्यू. तो अभी स्टेट क्या है, बोलो स्टेट क्या है, हेलो हेलो, टेल मी व्हाट इज द स्टेट, प्रेजेंट स्टेट
0.
0. तो 1-1 देखो जब वन 0 दी, तो अगर मेरा Q 0 आया तो Q जब मैंने 1-1 तो क्या आउटपुट,
0 ही है.
आउटपुट यहाँ पे क्या 0 ही है. मतलब क्या है, मतलब क्या है, मतलब जब 1-1 तुम दोगे, यही यहाँ पे एस डैश को 1 और आर डैश को जब 1 दोगे, तो वो जो Q वैल्यू में जो भी वैल्यू होगा, अगर 0 होगा तो 0 रहेगा, 1 होगा तो 1 रहेगा. वो कैसे चेक करेंगे, देखो यहाँ पे जब पहले क्या था, 0 था, अभी 0 रहा, अभी देखो वहां पे चेंज, स्टेट चेंज हो गया, जब तुमने इनपुट चेंज कर दिया, 0-1 कर दिया, तभी स्टेट चेंज हो गया, 0 से 1 हो गया कि नहीं, अरे हुआ कि नहीं, 0 से 1 हो गया कि नहीं, क्यों 0 पहले था, अभी 1 हो गया, अभी तुम उसी में 1-1 दिए, तो आउटपुट फिर क्या रहा,
फिर 1 हो गया,
फिर 1 हो गया. मतलब कोई भी स्टेट में अगर तुम इनपुट को 1-1 दे देते हो, तो वो उसी को मेमोरी आगे रखता है, मतलब उसको बोलते हैं हम नो चेंज. अगर वो 0 है तो 0 रहेगा, अगर वो 1 है तो 1 रहेगा. कौन से कंडीशन में, जब हम यहाँ पे 1-1 लाते हैं. हैव यू अंडरस्टूड, हैव यू अंडरस्टूड दिस वन, ये समझ में आया?
यस मैम.
ओके. अभी हम यहाँ पे अप्लाई करेंगे, तो यहाँ पे देखो एस डैश का एक्सप्रेशन क्या है, एस डैश इज नथिंग बट एस डॉट en bar. This is the NAND gate output is S dash. So S dash is equal to S dot en bar, which is nothing equal to S bar plus en bar. Yes or no? अरे yes or no, tell me.
Yes.
फिर R dash is equal to, tell me, R dash is equal to,
R into en whole complement.
very good, R dot en whole complement, which is nothing but R dash plus en bar. So here it is telling that when the en is 0 in the first condition, when the en is 0, तो अगर मेरा en 0 होगा तो ये मेरा क्या हो जाएगा, ये क्या होगा, 1 होगा, ये भी मेरा 1 होगा. ओके. सो वट एवर मे बी द वैल्यू ऑफ एस और आर, फाइनली मेरा एस डैश और आर डैश क्या रहेगा, 1-1 रहेगा. मतलब यहाँ पे वैल्यू 1 ही आएगा, यहाँ पे वैल्यू 1 आएगा. जो भी तुम्हारा एस का वैल्यू 0 हो या 1 हो, जो भी हो, जब तुम्हारा एनेबल अगर 0 होता है तो एस डैश 1 डैश आर डैश का वैल्यू क्या होता है,
1 ही होता.
1 होता है. तो 1-1 जब देखो प्रीवियसली लैच का देखो, जब ASR वैल्यू 1 1 होता है तो आउटपुट क्या होता है? नो चेंज, नो चेंज होता है। 1 1 जब आया तो अगर प्रीवियसली 0 था अभी भी 0 है, अगर यहाँ पे प्रीवियसली अगर 1 होता है तो 1 1 के बाद अभी भी 1 होता है कि नहीं? देखो ये क्या है? ये इनपुट है फॉर दिस लैच, दिस इज द इनपुट फॉर दिस एंटायर फ्लिप फ्लॉप। मतलब ये जो एस और आर दे रहे हैं, हम कहाँ पे दे रहे हैं? यहाँ पे दे रहे हैं, बट यहाँ पे हम लोग कहाँ? यहाँ पे दे रहे थे। मतलब प्रीवियस डायग्राम से मैं इसका एनालिसिस कर रही हूँ। किसका? इसका एनालिसिस कर रही हूँ, और इस डायग्राम में मैं इसका एनालिसिस कर रही हूँ। तो अगर मेरा एनेबल 0 है, सो एस डैश एस का वैल्यू तुम जो भी लो, ये वैल्यू तुम जो भी लो, एस डैश आएगा तुम्हारा 1 और आर डैश वैल्यू तुम्हारा आएगा 1। तो अगर मेरा एस डैश आर डैश वैल्यू 1 1 आता है तो व्हाट इज द माई नेक्स्ट स्टेट? व्हाट इज माई नेक्स्ट स्टेट?
1 ही होगा तो नो चेंज।
वन, ऐसा 1 नहीं बोल सकते, जो भी होगा वही सेम रहेगा। दैट इज नोन एज द नो चेंज। व्हाट इज द डिफरेंस बिटवीन 1 ही आएगा और माने नो चेंज? दैट मीन्स अगर 0 है तो 0 आएगा, अगर 1 है तो 1 आएगा। दैट विल बी टोटली डिपेंड अपॉन माई प्रेजेंट स्टेट। अगर प्रेजेंट स्टेट 0 है तो नेक्स्ट स्टेट भी 0 आएगा, अगर प्रेजेंट स्टेट मेरा 1 है तो नेक्स्ट स्टेट 1 आएगा। So that's why we're simply written as no change. Got it? Got it? First one. Have you understood this line? Now, if the value is 1, अगर मेरा en 1 होगा तो क्या होगा? देखो अगर ये मेरा 1 है तो ये वाला पोर्शन क्या हो जाएगा?
0।
0। ये भी मेरा 0 हो जाएगा। तो टोटली जो एस डैश किसके ऊपर डिपेंड करेगा? एस डैश इज इक्वल टू,
एस डैश होल कंप्लीट।
वेरी गुड। एस आर डैश इज इक्वल टू क्या होगा? आर बार। ओके, अभी तुम इनपुट कहां पे देते हो? इस एसआर पे या फिर यहाँ इस एसआर पे देते हो? कहां पे देते हो इनपुट? राइट हैंड साइड में, राइट हैंड साइड पे या लेफ्ट हैंड साइड पे?
लेफ्ट हैंड साइड पे देंगे ना, तो जो निकलेगा वो सर्किट का हिसाब से तो लेफ्ट हैंड साइड पे देना, वहीं से स्टार्टिंग।
नहीं, हाँ, तो मेरा यहाँ पे देखो एस डैश इज इक्वल टू एस बार, तो मैं इनपुट क्या ये एस ये एस को देती हूँ या फिर एस डैश को देती हूँ? कहाँ पे देती हूँ?
एस डैश को।
एस डैश को देती हूँ। देखो यहाँ एस डैश कहाँ पे है? अंदर है, सर्किट के अंदर है। तो मैं किसको देती हूँ? एस को देती हूँ।
वही तो हम भी बोले थे पहले, तो आप बोले नहीं।
अच्छा,
एस और आर को दे। You are not audible, man.
ओके, नेटवर्क चला गया था ना. Okay, I have sent the quiz link. Have you got it? Hello?
Yes, ma'am.
Which now? Siddhant Swarup? Hello, Siddhant Swarup?
Yes, ma'am.
तुम्हारा 2 बार लॉगिन क्यों हुआ है? 2 डिवाइस से क्यों होना क्या? दो बार तुम्हारा नाम दिखा रहा है.
मैं एक्चुअली उसमें माइक का वही इशू है.
So you are using both 2 device. Huh?
Yes, ma'am.
All of you quickly submit your quiz. Okay. Thank you all. We will discuss this thing in the next class. Okay. And within last 1 minute, all of you just try to complete the quiz. Okay.
Thank you, ma'am.